Problem 3-69. Multiply the expressions below using generic rectangles. So we've got 4 expressions here that we need to multiply. For part A, we've got the binomial 5m minus 1 times the binomial m plus 2. So our binomial, we have 2 terms by 2 terms, so we need a generic rectangle that is 2 by 2. Let's go ahead and set it up. For this side here, I'm going to do 5m minus 1. And for this side over here, I'm going to do m plus 2. Now, does it matter if I do my m plus 2 on the left side or if I put it on the bottom? No, it does not. I could change these, flip-flop them there, and I would still end up with the same answer. So let's go ahead and find the area of each part. So 5m times m is going to give us 5m squared. 5m times 2, because this dimension is 2, this dimension here is 5m. That would give us an area here of 10m. The area of the bottom right quadrant here, we have m by negative 1. Well, the area then would end up being a negative m. And negative 1 times positive 2 would give us a negative 2. Nice thing about the generic rectangles is a lot of times they leave us with like terms that we can easily see. In this case, it's this diagonal, 10m and negative m. So when we take this and we write it out here, to get our answer, we have 5m squared. 10m plus a negative m will give us positive 9m, so plus 9m minus 2. This is the area of our generic rectangle written as a sum. This is our area written as a sum. This is our area written as a product. So this is area as a product. I know some people get confused by that. That's why I wanted to point it out. As a product, we're multiplying them. As a sum, we're adding them together. So this is our area as a sum. Took each of the smaller pieces and we added it all together to get our area. All right, let's look at B now. We have 6 minus x and 2 plus x. Okay, if you wanted to take this and rearrange them, that's fine. You can do that. Just make sure you're careful because this x is negative then. If you wanted to rewrite this as negative x plus 6, you could do that. If you wanted to rewrite this one, it'd just be x plus 2. I'm going to go ahead and multiply it the way that it is already set up. I'm going to put my 2 plus x here, and I'm going to put my 6 minus x over here. As long as I multiply correctly, I should still end up with the same answer. So 2 times 6 is going to give me 12. 2 times negative x gives me negative 2x. X times 6, because this is 6, this is x, that gives us 6x. And x times negative x is going to give me a negative x squared. So when I take this and I write my answer out as a sum, I'm going to write it in standard form here. I'm going to put my negative x squared. I combine my like terms here. I have a positive 6x and a negative 2x. When I combine those, that means I will have plus 4x. And then I have my constant term at the end, which is 12. So I end up with negative x squared plus 4x plus 12 for my area written as a sum. Let's move on down to the remaining 2 problems here. For this one, we have 5x minus y. That quantity is being squared. This is one of the biggest mistakes I see in algebra classes, is because a lot of people just want to take their exponent here and distribute it through. But we have to remember that this means the same thing as 5x minus y times 5x minus y. So we're actually doing a binomial times a binomial here. So we've got 5x minus y, and we'll put our other 5x minus y. Since we're squaring a binomial, this should give us a perfect square trinomial as our answer. Let's see if that happens. 5x times 5x, well, 5 times 5 is 25. X times x gives us x squared, so we have 25x squared. 5x times negative y is going to give us a negative 5, because it's like saying 5 times a negative 1. And then we're multiplying that times an x and times a y. So we get negative 5xy. For our bottom right here, we've got 5x times a negative y. And you'll see here we will end up with the same exact thing, negative 5xy. And our remaining portion of our generic rectangle is negative y by negative y. Well, a negative times a negative is obviously going to give us a positive, and y times y is going to give us y squared. So we end up with positive y squared. Let's go ahead and write our area as a sum by adding our parts together. We're going to have 25x squared. When I take negative 5xy and I add another negative 5xy, that means I have negative 10xy. And the last part I need to add on is that y squared, so I'll add plus y squared. And I get my answer, 25x squared minus 10xy plus y squared. The last problem here, this one's a little bit different. We have a monomial, because it's just one term, times a trinomial. So instead of doing binomial times binomial, we're going to do a monomial times a trinomial. So we need a generic rectangle that is 1 by 3. So I'm going to take my 1, my 3x, I'm going to put it over here on that single side. And I'm going to put each part of my trinomial here in a different section along this side of my rectangle. So I have 2x minus 5y, or like a negative 5y, and positive 4 at the end there, plus 4. 2x times 3x will give us the area of this first part. That'll be 6x squared. Negative 5y times 3x. Well, negative 5 times positive 3 is going to give us negative 15. Then we have x and y. We're multiplying y times 1, more or less, and x times 1, because neither of them have any other x's or y's. And then we've got 4 times 3x, which should give us positive 12x. So the remaining part here, let's just go ahead and write out our answer. This is our area as a sum. We should have 6x squared minus 15xy plus 12x. Hopefully that has helped you with multiplying these expressions using generic rectangles. If you have questions, please make sure that you ask your teacher or seek help from someone else. This is all for this video. This is problem 3-69.